This video will discuss the solution to question 32. Figure 6 shows a particular dynamic memory implementation with CS is 10 femtofarads, CB is 100 femtofarads and VDD is 1 volt. What is approximately the readout voltage at node X for a stored 0 just before the sense amplifier is activated? And then 8 possible answers are given. So to repeat the question, we need to know what the voltage is at this node after this switch is turned on, which in effect will connect this storage capacitor, CS, to this parasitic capacitance, CB. If we can now draw an equivalent circuit of this, it would look like this. We would have this storage capacitor and this parasitic capacitor, which are not connected at all. They have an open circuit between them. Now we can compute how much charge each of these two capacitors holds. The storage capacitor stores a logical 0, which corresponds to 0 volts. So the charge which is stored here is the capacitance of it multiplied by 0 volts, and that will give us 0 coulombs of charge. The charge on this bit line capacitance, CB, is the capacitance CB multiplied by this pre-charge voltage of VDD over 2. So that is 100 femtofarads multiplied by 0.5 volts, and that gives us 50 femtofarads. When the switch here is turned on, these two capacitances will be connected like this. So they will be in parallel with each other with respect to ground. That means that we can think of these two capacitors in terms of one big equivalent capacitor, which looks like this. That means that this total capacitance should store the same charge as these two capacitors in the state before this switch has been turned on. From that we can actually compute the following. So that will be 0 plus 50 femtocoulombs, and that gives us 50 femtocoulombs. The capacitance of two parallel capacitors is just the sum of their capacitances. So that would be 10 femtofarads plus 100 femtofarads, so 110 femtofarads in total. And that gives us 455 millivolts of readout voltage at node X before this sense amplifier has been turned on.